So we're going to talk about another circular motion problem, specifically at an angle. So some of you might have been to Disneyland. If you have, you know what this ride is. If you haven't, you've probably seen it maybe on TV. That's basically, there's swings, and the people sit in the swings. And so let's put a swing. Here's the person. And the swings spin in a circle. So let me give you a few knowns about the problem. Let's go ahead and say the mass of the person is 70 kilograms. So this is a spinning swings. And let's say that the radius of the rope connected to the swing is 8 meters. And let's say that this is a 60-degree angle it makes with the vertical. Okay, let's go ahead and draw the free body diagram of the person. So we have force of gravity pulling the person down, and we have this tension force pulling up at an angle. So we're going to do a few different things. First, we're going to break our free body diagram into x, y components. B, we're going to find the sum of the forces in the x, y direction. C, we're going to find the tension in the string. D, we're going to find the velocity of the person in the swing. E, we're going to find the period. The period is the time it takes for one revolution. And F, we're going to find how many revolutions per minute occur. Okay, so let's start out with A. So at this particular point, here's our person. We already broke our tension down right here. And if this is let's draw it one more time, a little bit bigger. Tension, this is a 60-degree angle. That means there is a y component and an x component. Okay, so this is our tx and this is our ty. So if this is our angle right here, that means the cosine is actually the y, because the y component is the adjacent side to the angle. Adjacent, which gives us cosine, SOHCAHTOA. TOA. So ty is equal to t cosine 60, and tx is equal to t sine of 60. Okay, let's do part B. Let's write our force equations. Let's do our x direction first. It's the simplest since there's only one force. So some of our forces in our x direction are equal to ma, and our x direction, that is where the circular motion comes into play. So there is an acceleration, it's centripetal acceleration. So we only have tension in the x direction, which is equal to mac, and our tension in the x direction equation is tension sine 60. So let's go ahead and substitute t sine 60 equals mv squared over r. And we're going to leave that be for a moment and do our y equation. And the person is not accelerating in the y direction. That's going to equal 0. So our forces are tension y is up, so it's positive. Force of gravity is down, so it's negative, equals 0. So that must mean that tension in the y direction is going to be equal to the force of gravity. So let's substitute. We know tension y is equal to t cos 60, which is going to be equal to mg. So if we want tension, we can just go ahead and divide by cos 60. And when you plug in your givens, you get 70 times 9.8 divided by cos 60. You should get a tension of 1,372 newtons. So this tension we just solved for is not the tension in the y direction. Since we went ahead and multiplied our cosine 60, we accounted for the y direction already. Now we're taking the y direction out and we're just solving for tension. This is the overall tension of the string, not just the y direction, overall tension. That was part C. So let's go ahead and move on to part D. Part D is finding the velocity. So we're going to go back and use this equation we already wrote up here to help us out. Let's start with that. T sine 60, and the reason I'm using this equation is because it has v in it. And now that we know t, and we know m, and we know r, we can solve for v. So let's go ahead and solve for v, multiply r on both sides, divide by m on both sides. You get r times t sine 60 divided by m equals v squared. Take the square root. You get v equals the square root of t times r times sine 60 divided by m. Plug in our givens. We just solve for tension. So our tension is 1372. Our radius is... So our radius is a little bit tricky at this point. The reason why is because 8 meters isn't the radius of our circle anymore. The radius of our circle is right here. So let's go ahead and redraw that little triangle. I'm going to redraw it right here. So here is the pole in the middle. Here is our 8 meters. And here's our 60-degree angle. The radius is right here. Here's our 90-degree angle. So the radius isn't, oops, sorry. Here's our 8 meters, that's the hypotenuse. Here's a person hanging on the swing. And the radius of the circle is smaller than 8 meters, so we need to figure that out. Well, if we do our trigonometry, we'll notice that this is opposite. R is opposite to the angle. 8 is the hypotenuse, so we're going to be using sine. Sine of 60 is equal to opposite over hypotenuse. So r over 8. Multiply 8 on both sides. You get r equals 8 times sine 60, which gives you 6.92 meters. So it's important that we plug that r in, 6.92, because it is making an angle. Times sine 60, all divided by the mass, which was 70 kilograms. When you plug all that in your calculator, you should get 10.8 meters per second. Make sure you verify that that is true. Okay, let's do part E, which is finding the period. So in order to find the period, which is the time it takes for one rotation, we always use that velocity equals distance over time equation. And since it's a circle, we use 2 pi r over time. We want to solve for time. So let's go ahead and multiply time on both sides. So we get vt equals 2 pi r. Let's divide by v, divide by v. You're left with t is equal to 2 pi r divided by v, which is 2 pi times the radius was 6.92 meters, and the velocity was 10.8 meters per second. You plug that in, you should get 4.02 seconds. That's the time for one revolution. So now if we want to figure out part F, which is revolutions per minute, we know that one revolution takes 4.02 seconds. And we know that there are, since seconds is on the bottom, and I want it to be revolutions over minutes, I'm going to put minutes on the bottom, and seconds needs to go up on top so that it cancels out. Well, we know there's 60 seconds in 1 minute. Okay, dimensional analysis. You guys know how to do this. And you get 14.9 revolutions per minute, which is otherwise written as RPMs.